Hey, congratulations. You made it to part two with Mike the Virologist. In this section, we're talking about herd immunity and if you can catch this virus again. Don't forget to like, subscribe, and set up the notifications so you get informed when new ones come out. Another thing I want to touch back on a little bit was the herd immunity.
Hmm.
There was an article, I have it here, and I'll publish it in the description section below. It talks about a 2007 study, obviously about the SARS, the first
Hmm.
SARS-CoV-1 virus, and it talked about, in a way, herd immunity. It talked about our uh, pathogen levels building up, our antibodies, or sorry, not pathogen levels, our antibodies building up against this first SARS-CoV-1 infection or virus, and it says 2 years. We carried a strong population of these antibodies, which would be resistant to the virus, and then after the third year, it started to deplete. Is that also something to worry about? I mean,
Yeah.
if we do, like they say, 50, 60, 70% of the population get it before this thing could eventually eradicate itself based on herd immunity, is that something we might have to be worried about? Like, could we get infected again in 3 years?
Yeah. No, that's absolutely right. And so what they're doing is they're looking at what's called viral or antibody titer. So antibody titer, when I mention that, is just going to be how much antibody you have in your blood. And they can extract it out and just do an antibody ELISA, and they can actually quantify how much antibody you have in your blood. Or you can use like a viral epitope. And we can get into this is one of the ways they're testing right now. You take a piece of the virion, you take a piece of that spike protein, and you then put it on there and flush your blood over it, well, all the antibodies that you've made can stick to that particle. So then you can simply count those through some colorimetric assay or however you want to do it. And you can tell what your antibody or your viral or your antibody titer in your blood is at that point. And yeah, if it goes away in 2 to 3 years, like that paper you were just saying suggested, you may either have to get a booster every 2 years, or you might be able to be susceptible again, which is kind of when you get into what influenza was about, which is maybe it would have been a good idea for me to talk a little bit about that. Why we get infected with influenza every couple of years. And part of it is that you lose your ability to fight the disease every 3 or so years. When you combine that with the fact that that in influenza, there are a whole bunch of the H and N proteins, let's just call them that. Those are the surface proteins. And you have a whole bunch of different types. You have H1N1, that's the one everyone talks about. That's the Spanish flu. You have H4N4, you have basically H1 through H, I don't even know, I think it's eight or 10. Somebody I'm sure will comment on that. I don't remember what the top range is, but it's the same with N. So you have a whole bunch of different combinations of that virus that's going around, all the different H's and all the different N's. And when you combine that with your resistance to any one of those, it only lasts a couple years. That's why you can get sick with the flu every 4 years, even if you're getting vaccinated. That combined with the fact that they don't give you a vaccination for every um, strain.
So these multiple different H1N1, H1N6, whatever it may be, are these mutations? Would you call these mutations of the virus, to where the virus has a different spike protein on the end? So the H1N1, H1N6, for example, they're completely different, and you can't have a vaccine for obviously every combination of this kind of virus, right?
Yes, absolutely right. At
Okay.
one point, they were mutations. At one point, they absolutely were. When H1 became H2 from H1, it was a simple mutation or a number of mutations that resulted in that spread. And realistically, there are probably different H's that are in between there. Virus evolution, maybe we can talk about that a little bit later, is it's not like any other evolution you get into, because viruses don't breed with each other. Very rarely do they infect the same cell from two different virus strains, but they're always diverging. And the only thing keeping them together is natural selection. The pressure to bind to proteins, for example, on the host cell, or the you know, how to make a better polymerase. There's only so many ways to make a good polymerase. And if you stray too far from that, well, then you're not going to make too good of a polymerase. So we can talk about that later if it's relevant.
Yeah, well, I think it might be relevant now because there's another article, and this is more relevant than ever. And so sad for what's going on in New York. They're just being hit so hard, and we talked about this before, and with Chris, a brother. Um, because of their population density, New York was just, it was almost inevitable that something like this would happen. I mean, in walking around Times Square, I think it's something in the millions and millions of people pass by there every single day within a proximity of only a couple feet from each other. There's this in the city.New York. Um, it was an article just posted talking about, and this is kind of scary if you ask me, but 26% of the patients in critical care were between the ages of 18 and 49. So I would like to touch on that. And also, from my understanding of viruses, they're actually supposed to mutate to keep us alive because they need us to stay alive. So why would this be sending younger people to the hospital? And after, maybe we can touch on again how viruses actually mutate.
Mm. Okay, so one of the problems right now is that a lot of the elderly are, and not a problem, one of the great things right now is a lot of the elderly are sequestered in their homes. So they're becoming less contact with getting in less contact with the virus. These are these non-pharmacological interventions which are crucial to curbing this virus's growth and to actually reverse it. That's what China did. They basically sequestered everyone in their houses, and then the virus basically dropped to a level that the emergency rooms could keep up. And that's the whole strategy of this virus, right? The strategy of this virus is to simply simmer the burn rate down to a level that our hospitals don't become overwhelmed. Because when right now it's 19% based on some numbers of the people who get this virus are hospitalized. And so the strategy right now is if you can keep that rate low enough so the 19% who are hospitalized and require hospitalization can get hospitalization, you drastically reduce the number of total deaths. Because if everyone in America, for example, got this disease tomorrow, our hospitals would be overrun and we would have millions and millions of people dead. But if we keep it burning at a slow rate, our hospitals can clear the virus, can clear the sick people out. And which is one of the big differences also between this virus and um, the flu, right? The flu hospitalizations take 4 to 5 days. This can take up to 4 weeks before you're discharged from the virus. Therefore, you're on a ventilator. You're not on a ventilator for 2 days in the hospital, 3 days in the hospital. You're taking up a ventilator for a good part of a month. That's a massive
Wow.
weight on the ventilators. Um, so, as you were saying, that viruses tend to keep hosts alive. Um, One of the things about evolution is there is no there's only hindsight when you talk about things like that. The virus does want to keep you alive. You are absolutely correct in the sense that it wants to keep you alive so it can spread faster. Because if I get infected with virus 1 and you get infected with virus 2, and let's say we're twins, right? Um,
Almost,
then
but yeah.
sure, if 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 your virus keeps you alive longer and spreads more, well, it's going to have a better Darwinian fitness, right? The longer it can keep you alive, and actually the less your symptoms are too, right? You can continue to go about your normal ordinary lifestyle. And if you can go about your normal ordinary lifestyle, you can increase that R naught number that we were talking about, the infection rate. And so
Right.
instead of infecting 2 people, you're going to infect 4. Well, pretty soon my virus that I have that killed me, right, is going to basically die out of the population. Yours is going to be the predominant strain in the population. So it doesn't want to keep you alive so much as it wants to spread more, right? And this is a particular case that they've proven in these some of these real world examples. One of the cases, I'm not going to, I get a little excited sometimes, and I'm not going to get excited because this is a very serious issue. But there's this case in that. So what they did in the 1800s, 18th century, something, I know that's 100 years apart, but I don't remember the dates when they introduced rabbits to Australia. You spent some time in Australia, so this
Mhm.
may be relevant for you. Well, they introduced rabbits to Australia, I think it was 18th century. And what happened was these rabbits have no natural predators there, and they took over the whole island, continent, whatever you want to say, right? And so in the 50s, because once you introduce a few rabbits, right, rabbits do what they do, is they breed like rabbits, and they just swoop around the whole place. So what they did is they introduced this virus called the myxoma virus. And myxoma virus is a pox virus. It's a really horrible virus. you end up with, the rabbits end up with these large pustules that bleed, and it's a
Oof.
really disgusting way to die. And it was like, I think 98% lethal. Don't hold me to that number. That's from a virology
It
class.
was lethal.
98% lethal
Yeah.
when they introduced it, and it's carried by mosquitoes. So mosquitoes bite a rabbit, and they bite another rabbit. A mosquito could bite you. You can get infected with it. You won't have any symptoms or signs,
Right.
right? Like everything. Remember, you're always being exposed to viruses. That's something that they're around you everywhere. Um, so initially it was 98% lethal. And after the first wet season, it bloomed and took over the whole, and wiped out 98% of the rabbits. But then rabbits would reproduce and, do what they do. And then all of a sudden it came down. The number started dropping and dropping and dropping and dropping. And so the virus was the virus was resultingly keeping the rabbits alive longer, so they have a better chance of getting bitten by a mosquito and then spreading it to another rabbit. So it ended up, those are actually, results are being changed now. In the last couple of years, they've noticed the virus is resurging back to its more lethal levels. So it can switch right back too, if it finds a way to do that where it's still evolutionarily successful. But the same case is herpes, right? I mean, herpes has been with humans longer than we've been humans. 230 million years ago, the herpes viridae family came into humans. So
And to
herpes,
clarify, you studied this, right?
yeah, I used
Actually,
to
you
work
did
on this.
research on this.
Yeah, I used to work on cytomegaloes and herpes. It was in an HIV lab. Um, got to wear all the fun suits and do all that, do all that fun stuff.
Hope so.
Yeah, no, it was a very fun time. Um, but the herpes has evolved to a way that it's almost harmless for humans. You get a wound here, it's not too bad in terms of humans. I mean, I think anyone on our planet would rather probably get infected with herpes than they would this, COVID-19, get the symptoms of COVID-19, because it's been around so long. It can live with you your whole life, and it can spread to as many people as it can. That's really a well-evolved virus that's kind of been in there. Same thing we can say about HIV. There's a number of different viruses that have done it. On the other side, every rule, there's a counterexample. Some viruses have actually grown to be more lethal. So that's the grain of salt with that.
Right. I mean, it's if I ask my friends now, what would you rather have, herpes or COVID-19? I'm pretty sure most of them would say COVID-19, unfortunately.
Yeah. They probably most of them have herpes, but yeah. I'm not saying anything about your friends, Dave.
Yes, another one done. Go ahead, subscribe, follow me on Twitter and Instagram, and I'll be posting news every day.